block. So first issue is deficient rainfall and drought. So here we study the 21 years of rainfall data from the year 1998 to 2018. Here you can see there is a declining trend of rainfall from the year 1998. That is in 1998 it is 877 millimeter, and in 2018 that is 494 millimeter year. Between the 1998 to 2008, Chikli block experienced the 4 times moderate drought and having the 19% probability of moderate drought year. And this area experienced the water scarcity every year during the lean period from March to June due to the peculiar hydrogeological setup of the basaltic aquifer. The scarcity issues are very multifold. The second problem we are observing there is the declining water level trend. These are two different maps, that is the pre-monsoon water level data and post-monsoon water level data of the particular taluka. In the pre-monsoon, here we are studying the 10 years trend water level trend data for the Chikli taluka. Here you can see the decline water level in the yellowish color. The decline water level trend up to 2 years covers approximately 50% of the area, and in post-monsoon studies, that is in the November studies, the major part of the block showing falling trend. These are totally based on our CGWB conservation wells data. The third issue they have found is the limited groundwater potential. As all of you know, the major area covers in the Maharashtra is the Deccan Desert. So yield of the aquifer in the major parts of the block ranges from 1 to 2 LPS, that is the liter per second. And this is due to limited extent of porosity and permeability of the particular rock which is present in that area. Next one is increasing groundwater extraction. The groundwater extraction increasing with the year. Here you can see in 1997 the stage of groundwater extraction is very low, that is 28.34, which is increasing by the year, and up to 2020 it is 79.22. So in 2000 up to 2013 this block is categorized as a safe, but after the assessment of 2017 and 20, this block is converted into the semi-critical block. Okay, and here also you can see in 1997 this is the availability versus draft of that particular area, the groundwater availability. Groundwater availability decreases as the year increases versus the draft will be increases. So for the study of particular data, we are using some existing data, that is the 16 monitoring wells of the CGWB and 10 exploration data. And we are preparing the different thematic maps of that particular area, like geomorphological, soil map, geology and land use. In Chikli block, about 87% of the area comes under the moderately dissected perma, and soil 70% of the clay loamy soil mix is found in the block. Major formation is basaltic lava formation, and in the land use block, major part covers the kharif area. So when we talk about the aquifer geometry and characterization, the two main geological formations found here, that is the basaltic area and alluvial area in the river region. In aquifer 1, the hard rock is up to the 20 meter depth and weathered rock thickness from 8 to 16 meter. However, in aquifer 2, the depth is up to the 168 meter and fractured rock thickness is about the 3 meters. The yield potential of that particular aquifer for the aquifer 1 is 1 to 50 meter cube per day, and aquifer 2 is up to 1.25 meter per second per day. Sustainability of the both aquifers is limited, and wells normally sustain pumping from half hour to 3 hours. ज़्यादा चलता नहीं है आगे. Okay. So when we talk about the depth of water level data, these are the two maps where we study in CGWB, pre and post monsoon data we have observed for any studies. In pre-monsoon data, here major area occupies the 10 to 20 meter below ground level data, which is showing in the pink color. However, in post-monsoon, major area observed in 5 to 10 meter water level data after the monsoon period. Whereas in the deeper aquifer, you can see the water level is very declined, and major area covers about 20 to 30% area, and in post monsoon it covers major area covers that is the yellow portion, that is the 5 to 10 meter. And for the deeper aquifer we are using our exploration data. Here is not as much as quality problem. Only 3 villages found the fluoride problem, 4 villages found in the nitrate problem.
You have only 1 minute.
Yeah. I just didn't conclude this. So when we talk about the aquifer management plan of particular area, 2 terms are basically broadly used, that is the supply side management and demand side management. Supply side management, where we propose the artificial recharge structures in that particular area. Okay, so here in the Chikhli Taluka, on the basis of their unsaturated, because I have very short time here, so in Chikhli Taluka, the volume of unsaturated zone is 410, and the availability of surface in Chikhli block is 3 MCM, that is the million cubic meter. So here we propose the 11 percolation tank and 30 check dams, which will augment 2.32 MCM of water. And in the demand side interventions, where we propose where the stage of groundwater development is very high or water intensity crop is used. Here in the Chikhli block, whatever the cotton crop area is there, we proposed the drip irrigation, and because of this we save the water, and expected to save about 3.04 MCM of water. So I just conclude to the last. So as a part of supply side management, we augment about 2.32 MCM of water, and as a demand side management, in the 10 square kilometer of cotton area, we would save 3 MCM of water. And with the help of supply side and demand side management, we have total 21 MCM volume of groundwater generated to bring 0.32 square kilometer of area into assured groundwater irrigation, and with the average crop water required 0.65 by constructing 13 dug wells and 1 lower well in that particular region. So, with the help of the supply side and demand side management, our stage of development is reduced from the 73 to 69 by offering the good scope of groundwater development for the whole district. So, it's a small attempt to prepare a plan to manage the groundwater resource and arrest the further decline water level in the particular area by considering supply side and demand side. And obviously, the community participation will further strengthen the management of resource at Rashtrasant.
On groundwater modeling studies for estimation of canal seepage in the common areas of Pench irrigation project, Nagpur district, Maharashtra.
Co-chairman, respected member, professor, my dear colleagues from the University of RGA, and dear students. Here I have, my name is Venkateswaran. I retired from Central Groundwater Board, and I also work as a faculty in Rajiv Gandhi National Groundwater Institute at Raipur. And we have taken up the modeling study for estimation of canal seepage factor in the Pench Canal command area. You know very well that GEC norms are there for prescribed the criteria for various norms like specific yield, rainfall infiltration factor, and recharge due to other sources like canals, and return flow due to surface water irrigation, etc., etc. All norms are available in the GEC thing. And the problem is we are uniformly using those norms because these norms were established. For example, if you take the canals by inflow and outflow method or by ponding method, they have estimated the norms for the return seepage due to the canal irrigation. So those data are still in vogue. We are using it still now. And we can make lot of R&D studies in those norms. For example, for a percolation tank, the return seepage norm was reduced from 50% to 40% in the revised methodology of GEC 2015. So like that, I have made a small attempt because the norms prescribed was 25 to 30 hectare-meter per day per million square meter of the wetted area, that is the seepage norm. But if you take the GEC recommendation, we have to calculate the seepage factor during the monsoon season as well as during the non-monsoon season. So that if you take the monsoon season, there is a saturation of the Vado zone, and therefore the norms for the return seepage are supposed to be less when compared to the non-monsoon season. So that is why we have taken this study in the Pench irrigation project area Nagpur for using the modeling technique with the following aims: to decipher the existing groundwater flow regime in the command area, and to estimate the canal seepage factor during monsoon and non-monsoon season separately. The study area, it is underlined by 3 membrane meta sediments belonging to the saucer group. They comprise quartzite, mica schist, and manganese ore and marble. The main aquifer is unconfined in nature and caters to the all needs of the area. We have defined that hard rock system as a 60 meters as a total unconfined aquifer, and we have taken one layer for this model study. And you know very well for the groundwater equation, the basic equation is few slides about DEC. Inflow minus outflow equal to change in storage, that is the water balance equation. But if you take the inflow component, the main inflow component is the rainfall recharge due to rainfall. And the second one is recharge due to other sources. And third one is recharge due to resultant flows. Recharge due to rainfall, you know very well, this is mainly due to the precipitation. And second, the recharge due to other sources, we have recharge due to canals, we have recharge due to surface water irrigation, recharge due to groundwater irrigation, recharge due to tanks and ponds, and recharge due to water conservation structures. So for which all the prescribed norms are there in the GEC 2015 methodology. If you take the estimation of recharge due to canals is equal to wetted area into number of days the canal is flowing and a seepage factor. The seepage factor is available in GEC 15 methodology. And wetted area means wetted perimeter into length of the canal. Generally, wetted perimeter area you will get it from the irrigation department. If you don't get the value from the irrigation department, then you can calculate using wetted perimeter equal to 2 into average supply depth into upon side angle plus bed width. So that is the formula. And this is the cross section of the canal where you are having the full supply depth, and the blue portion is the wetted area, and you are also having the bed width here. And here you are having the side data, full supply depth upon the wetted side. So we know full supply depth, we also know the side angle. So we can calculate the wetted side. So wetted perimeter is equal to 2 into ASD, average full supply depth we are supposed to take. But generally canal will not flow up to the full supply depth. That is why we are considering the average supply depth, that is nothing but 60% of the full supply depth. So if you take the 2 means 2 sides of the canal. So 2 into average supply depth upon side angle plus bed width. So what is wetted area? Wetted perimeter into length of the canal, you will get the wetted area. So the norms recommended Pench irrigation canals, underlying canals were lying on the sandy soil with some silty content. The minimum value is 25 hectare meter per day per million square meter of the wetted area. The maximum seepage factor is 30%, and the recommended norm to be used in GEC is 27.5%. That is the recommended norm. So salient features, we are having the length of the main canal is 16,400, and bed width we are having 6, full supply depth is 2.8, side angle is 18. So that is the thing. And monsoon and non-monsoon running days also we have this thing. So we have consolidated the aquifer system as a single layer system, and it has got the rivers on the both sides. And on northern side there is a no flow boundary. The main source for recharge is recharge from the rainfall and also from the canal seepage. That is the main contribution factor for the recharge in the study area. And the groundwater is extracted by various extraction structures, especially for domestic and irrigation purposes. And the area receives recharge from the southwest monsoon season. Of course, we have also wished to have the one layer model, that is an unconfined aquifer up to 60 meters depth, and discretized into 32 columns and 40 rows. Grade height is 500 meters in the x direction and 650 meters in the y direction. And to accommodate the flow direction parallel to the cell pressure, the grid was rotated to the to 5 degrees, so that it will see the directions are parallel to the our observed contours. Hence, the major flow will be through the faces of the cells of the finite difference grade. So this is the model conceptualization we had, and elevations we have downloaded from the Cartosat. And if you take the model boundary conditions, we are having on the northern side we are having the no flow boundary, and there is a minor basin boundary was there. So we have simulated it in no flow boundary. And on both the sides of the canal system, they are having the perennial rivers, and that has been simulated with the constant head boundary. And the Pench major canal is running along the east-west direction, and it has been simulated with the help of the river flow package. And we have assigned the conductivity, hydraulic conductivity in all the three directions, and the storage values of the various zones of the area are also finalized and assigned for this area. So for example, 8.64 hydraulic conductivity in x direction is 8.64, same in y direction, and 10% of this thing is assumed to be in the KZ direction. And storage value, as per the GEC norms, we have taken the storage values we have taken, and we have assigned for all the cells. And the major source and sensing. The major source of groundwater in the rainfall is the rainfall due to, and this is computed from the rainfall infiltration factor method. The norms are available in the GEC that has been apportioned for the entire area of this grade. And as far as the sink is concerned, only the groundwater extraction by way of pumping of borewell is only extraction. The total extraction was estimated in the village-wise and well census data. The domestic extraction was also estimated based on the per capita requirement as recommended in GEC norms. So thus the total extraction was calculated based on the unit draft method and per capita water requirement method. And the model has to be simulated as per the protocol of the water flow. It has to be simulated in the steady state flow, and in steady state the hydraulic conductivity was adjusted to make the groundwater flow similar to the observed flow as per the contours preferred using the observation well data. We are already having observation well data for which we have prepared the contour map that has to be matched with this simulated thing. And then initial heads is nothing but for simulating the transient state, we need to assign initial heads as well as the storage parameters. So the initial heads were given and from the interpreted data using the water table measured in the field observation wells during May 2000. So at that time we were using PM5, processing mod flow 5 version was used. So afterwards I just for the presentation purpose I used this visual mod flow. The year was divided into two stress periods, that is the monsoon stress period and the non-monsoon stress period. Monsoon stress period we have assigned 4 time steps, and non-monsoon you know you are having 8 months, we can have 8 time steps for the non-monsoon season. And observation wells of the we have already established the observation wells, some 50 observation wells were there for which we are monitoring the water level for the 1.5 years from May 2000 to 2001. And after providing the required data, the model was simulated in the transient state and the heads were compared with the observed groundwater level. So this is the calibration of the 50 wells were used for calibration purpose, and we have achieved an RMS error of 3.3 meters we have assumed, and normalized RMS error was 5.52. So the correlation coefficient between the observed and computed head is 0.98, indicating the best match. So this is the hydrograph indicating the observed and computed heads. So I am skipping this, and then we have prepared the contour maps to see whether these maps are matching with the whatever we have prepared in the ground. So these are the norms I had told. 25 is the minimum, 30 is the maximum. So for after calibration, the canal inflows and outflows as observed in the zone budget, that is the mass balance, were noted for computing the seepage from the norms. The inflow from to the system or outflow from the system from the river package was noted as a recharge and discharge from the canals. And then for various test periods, we have calculated the inflows and outflows, and after calculating the inflows and outflows, the resultant flow with the number of days was multiplied and converted into hectare by dividing it by 10,000. And the norms calculated for each test period is averaged for monsoon and non-monsoon season. The outcome of this exercise was the canal seepage factor was 2.07 hectare per day per million square meter of the wetted area during the monsoon season, and for non-monsoon season it is coming around 23 hectare per day, and an average is coming about 13.64 hectare per day per million square meter of the wetted area. So this is the R&D study we have made to get the revised seepage norms. Okay, thank you.
Good afternoon, everyone. Here, Sinha Saab, Professor Saab, Professor, my dear friends. As we are running very short of time, so I think we have to be very. Myself, Dr. Subhash Singh, I was in Central Groundwater Board. So just I'm going to say about something about the Saraswati mystery. In our mythology, everybody knows that Saraswati is at Prayag. Many people, except scientists, but no scientists believe that Saraswati came to the Prayag. This is the things which have been made by the scientists. So, how I am going to say about the Saraswati at Prayag? Please see. We had done some geophysical and hydrogeological survey in part of Bundelkhand region. We did some geophysical survey comprised of geophysical tomography. We did several. We find in that area there were many caves and some good cavities which have very huge amount of water. Bhimkund. If you search on this Google, Bhimkund, here discovery people also came. They couldn't find the depth of this cavity. You see the water is purely blue, and below that at depth there was so flow that they couldn't go beyond that. There are so many things. Time is very short that I am speaking very fast. There are many cavities kind of things. This is Arjun Kund. If you enter in that kund, in cavity, you will find the ocean kind of thing, or you can say a lake kind of thing in the Arjun Kund. There are Patalganga, this is the same story everywhere. This is some Sadhva caves. This is another cavity which we detected by our methods. So, result of this tomography is that several low and high restricted regions which have been interpreted, clay, water field, activity, so many things. And we had drilled some borewells also. We drilled some borewells also surrounding. 3 borewells surrounding the Bhimkund inlet, enormous water, the limestone rock. Several studies done in the area indicated the depth of swimming pool is more than 80 meters because flowing groundwater depth of pool could not be measured. Depth of water level is about 30 meters. So there are so many caves, cavities and all kind of things. Water is flowing because there is no contamination, no stagnation, pure water. Then where it is going? The question is, if water is, if I say that where water is going, water is flowing, I have to conclude where it is going. Okay? So it either, if there is some flow, it will either go to the river or it will go to the ocean. That is there. Now once we thinking that how it is possible. So we saw, you see, this is the one picture. You see this is a very good picture. I can say lineament, but this may be anything. I am a geophysicist, so I could not interpret much. So you see this point is having 430 about elevation, and here is the Prayag. Here is the elevation is around 100 meters, and this is the Gupt Godavari in Pandav cave. If someone very close there, Maharashtra, there is Chitrakoot. Where is Gupt Godavari? If you go down and down about 40 meters for 50 meters, you will see flowing water. But where it is going, nobody can see. So, to think, we some think what is happening. So, we thought that if you heard about Bundelkhand region, if you see that so many part of the country which is occupied with granite formation and the same rainfall, but there is no such kind of scarcity of water that they are leaving their villages and migration problem. But there is a big problem of migration. So we think that these cavities are providing conduit kind of structures to the unconfined aquifer. That why the water in unconfined aquifer desaturating very fast. There is one Cane river which also crossing that lineament kind of thing which I have shown to you. When it crosses the river or that lineament, its discharge reduces. And also these are some facts. It is also fact that many volunteers around this lineament are getting huge water discharge after counting the cavernous limestone in Banda district. The borehole drilled drilling data Prayag area reveals that the basement rock near confluence is Vindhya limestone, shale and sandstone. So, as I said, this kind of activity, the lengthy, this cavities of limestone is common. About 650 kilometers lengthy limestone cavity has already been available in the United States. Even in Meghalaya and Telangana also there are very lengthy limestone cavities. So I can say that this which I am saying that there may be some kind of lineament and kind of thing that cannot be denied. So what I conclude that since there is no evidence have reported established that presence of Saraswati at Prayag, the myth of Saraswati river can be realized by the following. It is fact that more than thousands of years ago, the Saraswati river originating from the Himalayas disappeared in the wake of tectonic activities in the region. The rainfall had drastically declined at the time, which may have resulted in meager water flow in river Ganga and Yamuna or Sambe. During the same period, people might have noticed that some water flow coming from the subsurface at the confluence of river Ganga and Yamuna, and they might have thought that the last Himalayan river, Saraswati river, has reappeared at Prayag from subsurface, that is Patal Lok, and hence they named this place as Triveni Sangam. Linking all these observations with researchers' work of many scholars and myths already prevailing about the invisible river at Prayag, our study postulates that the unseen river Saraswati at Prayag is a groundwater flow which originates from the Bundelkhand region of Madhya Pradesh, follow the extensive deep lineament cavities, caverns, and converge to the confluence of river Yamuna and Ganga at Prayag, Allahabad. It is advocative that the nature and extent of these caverns may be further discovered by integration of various latest geoscientific techniques. Also, the study further suggests that the existing large prominent cavities may be developed as geodesia. Thank you. Yes, sir. अब इसमें ऊपर नीचे होता है, but that is different story. I am not going to that, so I am due to shortage of time. I am stopping. But I request all of you, please think about this and do something about Saraswati at Prayag.
Of fluoride in groundwater more than 1.5 ppm, it will be a threat for the human health, and that may be cause for the fluorosis, different type of fluorosis. And in my area, research area, most of the area is occupied by the agricultural land, forest land, but there is a lack of industries. So, and lack of dense urbanization. So, there is a very less chance of the fluoride contamination by the anthropogenic sources. So, our main focus on the geogenic contaminants for the fluoride. At the same time, we have studied the different type of hydrogeochemistry. Due to time constraint, we are skipping some of the slides. So, there are many of the factors which is affecting the groundwater quality: geology, land use pattern, climatic condition, hydrological condition, anthropogenic activities, dissolution, hydrolysis process, precipitation, adsorption and exchange oxidation, and many of the processes are responsible for the fluoride in the groundwater as a chlorine to fluoride in the groundwater. This is a fluoride geochemistry, different type of sources for the natural sources, anthropogenic sources, natural activities, and anthropogenic activities, which is responsible for the fluoride in the groundwater. So, is there a need of the fluoride study in such area? Because most of the area is occupied by the tribal people. Most of the area is actually state as a Naxalite region. So it is very difficult. There is a very less research work has been carried out by the different type of agencies, and whatever the work is carried out by the different agencies, that on a large scale map. So our focus to carry out the research, carry out the work on a small scale or a village level or zone level. To identify these are the objective to identify the villages area with a high fluoride contamination and delineate the different type of zones, high fluoride zones, to understand the depth and nature of aquifer that contributing fluoride in a drinking water, to recognize and study the geological formation responsible for the contribution of fluoride in the groundwater. But Rajula Korpan has some part of the GOP region also that we have added further studies. Carried out mineralogical studies of the main fluoride minerals present in the rock formation. We are not focusing on the hydrochemistry of the water source. Also, we are focusing on the mineralogy, petrography, and different type of allied techniques which can be helpful for the identification of the zones which contains the high fluoride aquifers. To assess the last one, we need to assess the effects of high fluoride on the villages and assess the different precautionary remedy measures to reduce the threat of fluoride to reduce the fluorosis cases. This is my study area in the Chandrapur district, the southern part of Chandrapur. So many of the countries, near about 30 countries or more than 30 countries, which is facing the fluorosis problems at a global level, and near about 25 million people which is affected by the fluorosis, and 20 states, more than 20 states of India which are facing the fluorosis problem. So first we prepared a different type of thematic maps before starting of the different type of fieldwork surveys. We prepared a different type of geomorphology, different type of thematic maps with the GIS and remote sensing and GIS tools. That one geomorphology, geology, lineaments, and drainage density, drainage maps, and tried to calibrate this data with the geological formation, geological lithologs, mineralogy, and different type of water parameters, geochemical, physiochemical parameters. The hydrogeologic characters of the major liquids in the area mainly control the hydrogeology of an area. Hence, the brief discussion of hydrogeological characters of the region has been discussed and studied. The natural phenomena which are influenced by the geological setting of the region and hydrogeological condition are the important factors for fluid occurrence in the groundwater. In the study area, main hydrogeological formation which is responsible, which is favorable for the water movement, because water movement, occurrence and movement is responsible for the fluid transportation in an underground environment. So many of the geological formations like Deccan Trap, Gondwana sandstone, Quaternary alluvium, Vindhyan limestone, Archean metamorphics, means from the basement massive complex to upper Quaternary, all the formation which are those are present in my in my research area. So there is a complex geology mixing of the a different type of differential aquifer system, and due to a differential aquifer system, differential geological condition, there is a hydrological condition is also a complexity in nature. This is the drainage map of study area. The main waters, main river water, which attached with the Panganga formation or Gardari, Panganga and Varda river system. These are the tributaries of the Godavari system. This is the geological maps, and this is the geology of the study area. We can see Archeans, from the Archeans to a recent alluvium size to a sandy clay size of quaternary deposit which is present in the study area, and different type of geological formation, different type of geological units are present in the study area. By different type of geological, geophysical techniques at the fieldwork, field surveys, we have prepared our lineaments map and demarcated a different type of fault zones, because lineaments also play a vital role in occurrence and movements of the groundwater and fluid enrichment due to a leaching process, weathering process. This is a methodology we have adapted due to a time constraint. We will skip some of the slides. Then near about 100 groundwater samples we have collected, near about 23 oil well samples, 77 dug well samples we have collected. The hydrogeochemical characteristics of the groundwater based on concentration of major ions chemistry. For drinking and irrigation purposes we have studied. The X-ray diffraction study we have also carried out. Analysis data of soil samples as well as rock samples we have studied. And data, soil and rock study data that we have calibrated with the petrographic analysis. This is a comparison of groundwater samples with the BIS drinking standards, in which we have the pH in a normal desirable limit, but most of the samples they falls in a critical to semi-critical condition, means desirable to maximum permissible limits. So our fluoride, most of the samples, near about 77 samples, they falls in a maximum, they cross the maximum permissible limit. Means in a preliminary survey we have collected near about 460 samples. Out of 460 samples we have taken only 100 representative samples, and here you can say future state is increasing, and 98% also of future state for the people from the Chandrapur district. On the basis of fluoride data, fluorosis data, we have demarcated different type of zones: safe zone, partially problematic zones, and problematic zones, and highly problematic zones. So most of the villages from the Chandrapur, southern part of the Chandrapur district, also some of the eastern parts of Aurora district, whatever the area, also covered attached with the southern part. That also falls in a problematic zones which are having the fluoride content in water, 1.5 to 3.0 mg per liter, and above highly problematic zones near means 3. The concentration of the fluoride in the groundwater is more than the 3 milligram per liter or 3 ppm per milligram per liter. And we got the highest fluoride concentration in the groundwater is 7.24. It is the most safe concentration for the people. Let's give some of the slides. This is the fluoride map, special temporal evaluation map of the fluoride concentration. We can see most of the fluoride, which is here about 7.14 ppm occurs in groundwater. Then we have different petrographic analysis. These are the petrographic results. Where we get a different fluoride bearing minerals. Fluoride bearing minerals means whatever the fluoride means. We didn't get the fluoride directly in our groundwater as a fluorine ions, but fluorine ions may be formed with the different type of fluoride bearing minerals like a clay mineral, fluoride, biotite, azurite, agite, apatite, fluoroapatite. In a very rare condition, we get the fluoride as a fluorine ions. Okay. So, means primarily there is not fluoride in a rock, but fluoride is present in the groundwater. So, this is the main phenomenon that occurs in the study area. So, whatever the result we got in petrographic, XRD and physicochemical analysis that we have calibrated, correlated and found the source of the fluoride. So, many of the formation in Deccan formation, Deccan traps, basaltic lava flows, there is a limestone, calcite is showing the first interference color, then the section of microphotograph of granitic gneiss which contain amphiboles, then potash feldspar, heterogeneous minerals, some of the fluoride and means like a micro monomoldolite, like this type of clay minerals also contribute on much of a fluoride, fluorine bearing minerals as the forms of fluoride in the groundwater. Then we analyze the XRD. So these are the XRD patterns where directly we get the elite, monomonite, muscovite. These are the calcite. Then these are the fluorite, labradorite, agite. These are the different type of fluoride bearing minerals that we get in the XRD analysis. Then we analyze the water phase with the different type of graphical representation of the groundwater data with the help of hypertidal diagrams. Then with the Doro plot and the rock water interaction with the Gibbs plot, it clearly mentions the water, whatever the pollution, whatever the groundwater contamination in concern with the fluoride, that due to rock water interaction. This is the correlation analysis. It clearly mentions the CA is showing the strongly correlation with the fluoride. It means whatever the CA that goes from the fluoride bearing minerals that will be added as a CaF2. So it may be a cause from the fluoride source as from the geogenic sources. So this is my conclusion. The different type of geochemical parameters is showing the intrinsic trends of the contaminations as a fluoride bearing minerals. So petrographic study of different elements were carried out for finding the genesis of fluoride and its insertion from the basaltic rocks, from a different type of units, from the Vindhyan formations, from the Gondwana Kamki formations, they contributing the fluoride, and some of the rock units from the Baraka sandstone. Baraka sandstone is a heterogeneous sandstone, which is a heterogeneous means Fe is a source, Fe and Ca from the Deccan, which from the CaF2 as a fluoride, from fluorine to fluoride in a groundwater. So we prepare different climatic maps. Then the groundwater with a high bicarbonate content, which from the
Please conclude. because the time is long.
The groundwater from the bicarbonate with high concentration of bicarbonate from the carbonaceous rocks from the Vindhyan formation, it may be a
Finding is coming.
So the other recommendation. Thank you.
A very comprehensive work, but I'm sorry you have to, time is not that much available. These things are
Thank you very much, guys. Now,
Amit
Shilke, topic is mapping of land sites sustainable roads in and around Spartan, Satara district, India, using groundwater flotation, implications and funds.
Mapping of landscape susceptible zones in and around Patan, Satara district, India, integrating GIS statements. So this is my study area. My study area is located in and around Patan Taluka, which is southwest region of Satara district, which include Koina, Kera, Murga and Wagner river, and it covers around 625 square kilometer area. So this is the landslide susceptible areas are observed and detected by imagery and aerial photograph interpretation. So using a study of networks, we have procured digital elevation model of altimeter resolution, and from that we have prepared a map. Using topo sheet, we have digitized the drainage, springs and road map, and using those special tools, and then from that we have prepared density map. Using sentinel to satellite imagery, we have prepared lineaments and normalized difference, vegetation index, and land use land cover map. Rainfall was procured from NASA's TRMM sites, and earthquake centers and various landscape data was procured by Bukosh from GIS. So from the district resource map of geology, we have observed that the area is covered only by basaltic rock, and in some region laterite is overlaid by basalt. Stronger rocks resist the gravity forces better than weaker rock, and weaker rocks are more prone to landslide. In this area, basalt is more stronger, but the joints and cracks making it weaker. So, geomorphology, the western region is mainly of dissected laterite capping, and central region and eastern region is mainly upper plateau. The water bodies like rivers like Koina, Morna, Kera and Wagner flowing through my area. And lineaments. So lineaments are structural linear feature which are weaker zone fractures and faults. So these are more likely to these are reasons behind some landslides. So landslides are more likely to occur along lineaments which shelter not just surface material structure but also contribute to terrain permeability, and density of lineaments is more towards western and central portion of my area. Drainage density. So drainage density map we have generated by using topo sheet. calcareous soil, clay soil are present in my area, but loamy soil is morely dominated. We have generated slope maps using SRTM 10. Then the annual average rainfall of the area is 2,522 millimeter. It varies from 909 millimeter to 4,135 millimeter. And rainfall is the main factor behind the landslides. In 2021, there were many landslides occurring in Western Ghats, and all these are rainfall triggered because in 21st, 22nd and 23rd July 2021, there were around more than 800 millimeters in 24 hours. So rainfall is the important factor behind it. In spring density, springs are peculiar output of the Deccan geology, which is multi-layered, always and impervious. The density of springs are more in central and northern region. So, this is physical elevation model, land toward back. We have generated total 13 layers. So, using weighted overlay analysis, we have ranked all the layers and classified it, and then we assign weightage to each layers. Using weighted overlay approach, we have made the landslide susceptible zone map of Patan Taluka. So 34% of the land comes under a very high landslide hazardous zone. And the conclusion of the present study illustrates the landslide hazard zonation of southwest Ghats of the Maharashtra. Weighted overlay technique is used for landslide zonation, which shows 34% of the study area is vulnerable to high to very high hazardous zone, and 48 and 80% is moderate to low hazardous zone. And the villages like Morgiri, Koinanagar, Rasati, Rokawade and Ambegar are prone to landslide, and that Karachipur road is also susceptible to landslide. Many rockfall were recorded previously. And, for mitigation purpose, this map can be used for. Thank you.
Hello. No, do it. Thank you.
Monitoring the spatio-temporal.
Good evening to all. Myself, Rashtrasant Tukadoji School of Environmental and Earth Sciences. With prior permission of chair, I am here to present my topic. Its impact of climate change on groundwater and water. Due to the shortage of time, I will start and I will try to complete it as soon as possible. We will go by step by step. I will start with an introduction, then go to the impact of groundwater resources, the impact on river, the lake, and finally on the mitigation process. Mitigation measures. Introduction. As you all know, groundwater will be impacted by climate change in both qualitative and quantitative ways. The climate change poses uncertainty to supply and management of water and resources, even though the government has tried and even the panel of climate change and define the average weather in the terms of mean and variable over a day in certain areas, which is now with a decade of time and climate impact will after occur. Here I have incorporated the water cycle. As you all know, climate change, the temperature and precipitation are important reflections on all aspects of the hydrological cycle. The impact of groundwater resources. The increasing variable in precipitation and more extreme weather events causing by the climate change can lead to the longer period of drought, flood, which directly affect the availability and defense of groundwater. The people in water-steady areas who depend on groundwater will be suffer. Impact on rivers. As I have mentioned here, the severe drought in California travels over the river beds. The pattern is shifting due to the climate change and the lifting of some regions. Additional water is snow and all other. Impact on rivers. As I have mentioned, the water quality degradation from likely increase the abundance of noxious and the change in water temperature affect the metabolism and even the other aquatic animals or organisms which are living in the lakes also. As we have gone through the impact on groundwater, impact on lake and impact on rivers, the mitigation measures need to be mentioned here during the conclusion. We have understood that addressing water scarcity requires a multidisciplinary approach. The public education is a key factor for the conservation of water conservation. The industrial source of water pollution should be regulated as a point of pollution. And finally, rainwater harvesting for all good functions and reacting the water can be helped to tackle this overall measure which has happened to the climate. Finally, I would like to thank the Indian Science Congress and everyone Dr. A.K. Sir, the President of IIT for giving opportunity, budding scientists, budding geologists for platform such a good event. Thank you.
Last lecture of this session is by delineation of groundwater recharge potentials using integrated fuzzy AHP method and hydrospatial modeling based approach.
Before that, I'd like to say a few words about Dr. Kalam. Dr. Kalam is one of the executive members of our council, and this session has been organized because of his unfailing help, support, and all the labor he has put in. So give a big.
Good evening all. Myself, Dr. Ajay Kadam. I am a postdoc fellow at North Maharashtra University at Department of Applied Geology. My topic of today's presentation is delineation of groundwater recharge potentials using integrated fuzzy and AHP method as a hydrogeological or hydrospatial modeling based approach. Basically, we know all this about groundwater last 1 hour, about what is groundwater and other things. So here what we mainly focus is just what are the different methodologies that we can identify with a minimum number of layers or a thematic layer with different types of methodological approach. So how we can go with identify many good accuracy of the data or good accuracy of the output map. For that we are using AHP, that is analytical hierarchy process, as well as fuzzy logic and integration of both to get more and more accuracy of the area. So this is my study area, that is more river watershed, that is area about 1187 square kilometers. Basically this is area is mainly present in northeastern part of Jharkhand district, having semi-arid region. So because of that we mainly focus more on groundwater potential recharge and identification. So the main aim of this study is to identify which methodology is more adapted or which applicable for the study area. So we use all basic layers like geology, soil, then drainage, lineament, slope, latitude, landfall and rainfall data, and we do various type of permutation and combination. Like first we use AHP, that is analytical hierarchy process, then we use fuzzy logic to identify groundwater potential zone, and then we use integrated AHP and fuzzy logic method, and then we do all this with weighted overlay analysis to get finally ground water potential zone map. We validate this data with the help of different layers like groundwater level data, groundwater fluctuation data, as well as groundwater yield data. To get more accurate where it is happening. So we use these basic layers like geomorphology, identify different types of geomorphological features are present over there, like pedoplane, alluvium plain, and other things that are present in that study area, as well as what is the geology of the area. This is mainly we have found out that the alluvium plain is mainly present. Then we have identified different land use land curve. We use list score as well as cartosat image, list score and landsat image to get a more accurate level 1 classification of our study area. Then we use next, that is drainage density. We classify data into 5 different classes like very low to very high drainage density. We identify different soil hydrological soil group, that is HS, G, B, C, D, that is loamy soil to clay soil in our study area. Then we classify that slope of our area into 6 or 7 different slopes, starting from plain land to escarpment. Then we get rainfall data from various sources, like there are meteorological stations data also. We use Thesian polygon as well as TRMM data. We club that data to get more accurate result of our area. Then these are various layers. I don't go in much detail, but these are layers we got from our area, and based on that we classify that data. Based on these, some of these, how it is affecting the groundwater potential recharge. So where it is high, we give a higher weightage. Where it is low, we give a low weightage. For that, we use this first method, that is AHP, that is analytical hierarchy of process method, where we have it is in this. If it is less importance, we use in fraction. If it is more important, we give rank as a 9. So AHP has a value from 1 to 9. If it is a low weightage, it is given as a 1, and if it is having a maximum weightage of for recharge, we are giving 9. So in simple example, if we have a sandy soil, it is having more porosity and permeability to recharge water, so we give a value of 9. I mean, if it is a clay soil, it acts like a impermeable layer, so we give as a value 1. So based on this, we do first AHP analysis. So these are the steps. I don't go into details, but these are the steps that we follow. We use this final groundwater potential zone map index that we develop, and these we utilize for getting how much is the recharge. So next method that we use is fuzzy logic, where it is it divide the value from 0 to 1. So based on this, there are set of softwares, open source as well as license versus software, that we can use the fuzzy logic tools that we are utilizing for different indicators. For this, we use the groundwater recharge potential index in multiplication. That is, if you multiply each layer by dividing 0 to classifying 0 to 1. So whatever values we identify the groundwater potential zone. So then what we do is we do combining of both. That is, we use weightage from fuzzy logic and weightage from AHP, and both combining, we finally get this groundwater potential recharge index. That is all the values we are summation, that is in this table you can identify that we are getting weightages from AHP and multiplying with the fuzzy logic, and we get finally the fuzzy membership values. So these we combine, and then we got this groundwater recharge potential zone map. We reclassify also this map with a different permutation and combination of layers as well as methods, and we do the accuracy assessment of this with the help of different layers like AHP, groundwater fluctuation, groundwater level data as well as groundwater yield data, and we found out that integration of AHP and fuzzy logic, we get a maximum accuracy of 80 to 85% with the help of this. So these are the some conclusion.
With this, I invite our co-chairman to be here. Chairperson, please. And I request Pachuresa to join. Thank you. Thank you very much. I'm really happy and I appreciate your participation. And you know the INCI membership is annual membership, and which runs from January to December. Now the membership renewal or new membership has already started for this month. Those who have not joined, I request them to become member of INCIH and help the country, society in proper understanding, development and management of groundwater. So with this, I thank you again for your participation and hope we will keep it and we keep on meeting very frequently like this. Thank you very much. Particularly, I am very thankful to our senior people.
What is the annual fees or it's a lifetime?
Yeah, just I announced for the working person, it is an online membership, 2,900. For retired person, it is 2,000. And for student, it is 1,100. And this is annual. This is annual. And details of the form and other thing, Dr. Kadam may circulate it to all the members and participants.
And you can visit the website also.
Also you can go to
IH main
we
and
have the
INCI.
INCIH website also.
Lot of literature is there.
There.
Everything that is produced is mostly, INCIH newsletter is available free of cost. So
IH website is also there, IH.org. You can go there, you can get what Patrice have told that you get lot of literature, lot of information about all the country, the groundwater, because in the context of India, Dr. Lemian has written and edited some groundwater memoir also pertaining to India, how the groundwater is helpful in removing the poverty and all that. So such things have come, and there are many journals, books which are there loaded on the site. INCIH website is also there, and you can go and you can see our e-journals, newsletters and other activities which have been carried during the last years. So you will get every information, and anybody interested can contact us. Thank you very much.
The first presentation of today's session 4, the hard to onset of late Cretaceous Deccan volcanic eruptions, evidences from mega and microflora. So we will be starting, we are late, actually it start at 14:25, it is 14:50. 2:50 हुआ है. So we will get 10 minutes for presentation and 5 minutes for interview. As per the schedule. You can start.
Good afternoon everyone. I'm Neha Thalke, PhD student from Department of Geology, RT Avenue, Nagpur University. My topic of presentation is onset of late Cretaceous Deccan volcanic eruption, a boon or bane for the flora. Evidences from mega and microflora of Malwa group. So I'll briefly introduce the Deccan volcanic province, which the Deccan late Cretaceous early Paleocene Deccan volcanism is one of the largest continental flood basalt province. The volume of this volcanism is 1.3 into 10⁻⁶ cubic kilometer. The area this volcanism the province covers an area of about 5 lakh square kilometers, and the duration short of about less than 1 million years to long about 5 to 7 million years. But recent studies indicate that the extended duration is about 5 to 6 million years with its peak at 1800. The KPG extinction, which is Cretaceous Paleogene extinction, is the second largest extinction event. Possible cause of this extinction could be Deccan volcanism of India or Chicxulub impact at Mexico, or can be both. So the DVP associated sediments are infratrapians and intertrapians. So infratrapians are those sediments which are usually Deccan lava, and the intertrapians are sandwiched sediment or flows associated sediments which are deposited in between the lava piles. These are mostly deposited in small lakes and ponds in the fringe areas of DVP, which is generally of 2 to 5 meter thick, or rarely it can be 10 to 15 meters, and mostly represent a few hundred to few thousand years of sedimentation. Now, the classification of Deccan flows, which is given by GSR, based on petrography, geochemistry, and magnetostratigraphy, and flow mapping, flows are classified into groups, and these groups are further classified into formation. So there are Sahyadri group, which is considered as mostly the main Deccan volcanic group, or the main Deccan group, volcanic group, which is below the Tapi river. Then there is Satpura group, which is in between Narmada and Tapi river. Then there is easternmost Amarkantak group. Then there is Malwa group, which is the northernmost lava pile of Deccan volcanic province. Then there is parts of Saurashtra and Kutch which are unclassified. Then I will briefly tell the geology of the study area. So my study area is in Dhar district of Madhya Pradesh in Malwa group. So Malwa group covers an area of about 50,000 square kilometers, which is the northernmost lava pile of Deccan volcanic province. This where the flows are underlain by lametta formation or the bark. It has 46 basaltic flows, and thickness is about 730 meters cumulative. The Malwa group is further classified or divided into 6 formations. The lowermost is Mandleshwar, followed by Kali Sindh, then Kankaria Pirukeri, Indore, followed by Barmunda, and above the younger one is Singarchori formation. These intertrapian beds are present only in lowermost 2 formations, which is Mandleshwar and Kali Sindh. In Mandleshwar we have 7 flows and intertrapians are at 7 level, and in Kali Sindh we have 11 flows and intertrapian is at 1 level. Then these are the few field photographs of my study area, which can be seen as Bagwania intertrapian, and my second locality is Timaria intertrapian, and the third is Imlipura intertrapian. These are the lithosection of my study area, or the intertrapian localities, where we can see 3 lithosections. First one is Bagwania, where the palinomorphs are present in Cherty shale and carbonaceous Cherty shale. In Timaria intertrapian lithosection, palinomorphs are found in uppermost Cherty hard shale, which is this. In this part of lithosection, and in Imlipura, where the palinomorphs are present in both the yellowish brown hard Cherty shale, laminar shale, and the above one black hard chert. So pollens are reported from this 2 part of this lithosection. Then these are the palinomorphs from the study area. We can see good palinoflora are reported from this Bagwania intertrapian, and then these are from Timaria intertrapians. There are few marker Maastrichtian palinomorphs which indicate which are as follows, like Azola, Cretaceous, Gabonus, Sporis, Vergioxis, and the followed by these. These are few marker Maastrichtian palinomorphs from this intertrapian localities. Then these are the palinoflora and leaf impression from the Imlipura intertrapians. We can see the palinoflora like Azola and Gaboni, and then this is the leaf impression which can be seen. We can see the leaf venation in this rock samples. stratigraphy of Mandleshwar formation, where we have reported good floral diversity at 3 level. So it is already given in names as number 1. Then at second stratigraphic level there is this is number 4, and at higher stratigraphic level called number 6. So first one is my Bagwania intertrapian, the 4th number indicates the Timaria intertrapian, and the 6th number indicates the Imdicura, which is at higher level of my studied area. So this indicates in this area few vertebrate fossils and paleomorphs are reported from this Mandleshwar formation. This whole section is of Mandleshwar formation. Above it we have Kalisin, where only one intertrapian is located at Tukala, where the bones of sauropod is already reported by Mobe and Salmon 2009. So paleomorphs are present at 3 stratigraphic level. The lowermost, which is Bagwania, has aquatic forms of paleomorphs. Then in Timaria also has aquatic forms of paleomorphs, and in Imdicura we have aquatic as well as terrestrial forms of paleomorphs. We have also got this leaf impression and fossil wood from the Imdicura intertrapians. Then, as I am the first year student of PhD, so I could not conclude from this little part of my study. So I say it as an interpretation. So based on my whatever I have studied, I'll give you some interpretations. So Deccan volcanic flows of Malwa group are classified into 6 formations, which I already mentioned before. So lowermost Mandleshwar and Kalisin formation has the intertrapian sediments. And the intertrapian sediments in the associated flows are considered as the oldest lava pile of Deccan volcanic sequence. The intertrapian sediments were deposited in Maastrichtian prone 30 normal at multiple stratigraphic level. The good palinoflora is reported or recorded from 3 stratigraphic levels, which I have already mentioned, this Bagwania, Timaria and Imdicura. This palinoflora shows good floral diversity. All the studied intertrapian sediments of marker Maastrichtian paleomorphs. This studied area of intertrapian flow shows the good marker Maastrichtian paleomorphs, which I have already mentioned, like Azola, Platypolis, Jansopolis, and dominance of Gabonicornis vergioxis and Aquila polonitis bengalensis. At the lower stratigraphic level, which are Bagwania and Timaria, shows aquatic and semi-aquatic flora. Then at higher stratigraphic level, which is Imdicura, shows aquatic, semi-aquatic with woody arboreal flora like terrestrial trees are present there at higher stratigraphic level. If we do the comparison of this intertrapian and infratrapian, we can say that the infratrapian was dominated by gymnosperm, angiosperm dominated flora, versus in intertrapians, which is my study area, is dominated by pteridophyte angiosperm flora. So this comparison, we can say this Deccan volcanism was not detrimental or bad for floral diversity or for the plant growth. It just changed the floral diversity or the community. In fact, it facilitated the diversity in angiosperm plant. Basically, and one thing, it established that time the flora was establishing gradually in time. So volcanism just changed the climate from semi-arid to arid during infratrapian to humid to subhumid during the intertrapian, which indicates my study area. So these conditions mostly facilitated the growth and preservation condition of flora. That's why we get good amount of angiosperm community, pteridophyte community of flora. So these are few references of my study. And then I would like to acknowledge few people. First one, UGC NET, which is my funding agency. Then the Department of Geology, which gives me good working condition or working facility. Then Dr. Bandana Saman, which gives me immense and valuable guidance because she is my guide for PhD. Then Dr. D.M. Mobe sir for his valuable guidance. Professor Satish Sambode sir for his support value magnetic facilities. Then Mr. Anup Dhobre, which is the senior SRF, senior research fellow from SPPU, and then this 108 Indian Science Congress RTM Nagpur.
So,
Session is open for discussion.
you have shown one leaf impression. So, did you get any kind of climatic situation in it by taking leaf impression? Is it indicating something about the climatic conditions?
We can say, by looking at it, we can say these are from angiosperm community, and then angiosperms were organized in this. We cannot directly say about the, but yeah, this
By the
vanishing
nature of the
pattern.
leaf, is it possible to realize something?
Yes, sir, because different type of leaf pattern and vanishing pattern is different from different environment. So we'll mostly get the reticulate pattern of leaf, and then the plain pattern depend upon the environmental condition.
So, it's not clear here in this impression.
We cannot clearly see that. We can see the clear vanishing pattern, but the leaf outline we cannot see here. But this is because the vanishing pattern is, we can see vanishing pattern here. This can be clearly say about the angiosperm flora. This leaf is of angiosperm, because the gymnosperm will have this parallel vanishing pattern. So, and again the outline of leaf can give the information about the plant. I cannot tell you much. I haven't studied much on this.
Anika, again I want to know, you have said that there is change in the weather from arid to semi-arid. So what are the difference between the pollens you have observed during semi-arid condition and in arid conditions?
Semi-arid and arid and semi-arid conditions was there in infradrapines, right? In Lametta we didn't get much floral record from my study area, but we have recorded like sir and ma'am have recorded floras from Lametta, Nan Dongargaon basin. There we got this semi-arid and arid perinomorphs. Should I name them? Yeah. These are classopolis, then cycalcopolis, then compositopollinites, then Cretaceous poraites.
So these suggest the arid climate or the semi-arid climate?
Ma'am, these are from this arid and semi-arid climate.
Both at the same time? Because you are saying that it is
It is from semi-arid to
semi-arid to arid.
to
So what is the difference between the semi-arid, the pollens which you have observed in semi-arid thing and the arid? Is there any morphological changes in the
Yeah, we can see this like this. If we are seeing this, we can see some ornamentation pattern differences. Like here, if you are seeing this, we can see spines or these pollens. So that can be indicate this arid, semi-arid or arid. But I cannot give you clear information of the distinction between semi-arid and arid. But there are ornamentation pattern which can give you the clear.
Okay, that means there is morphological changes in the
Changes.
pollens of arid climate and semi-arid.
Yes.
So it is our first year, so more of what she has presented is observations only.
Yeah, these are
Observations
from
are what that she has presented observations. So,
Nice presentation. I totally understand.
second is paleomagnetic polarity. Is there? Is not.
He was not supposed to present.
Isha Daya Goreswar. Identification of suitable site for artificial recharge research in different lab. Okay, Ms. Goreswar. 5 minutes.
Good afternoon, sir. My
research scholar in the PG Department of Geology, Rashtrasant Tukadoji Maharaj Nagpur University, Nagpur. Today I am here to give presentation on the topic identification of suitable sites for artificial recharge measures in the central part of the Abhivaje to watershed Deccan basaltic terrain, Maharashtra state, India. This is the location map of the study area. This is the general information of my area. Tehsils are Gadol and Nalpet. Basin is the Varda River Basin. Sub-basin is the Jam River Basin. Proportions included are 55 k by 11 and 55 k by 7. Total area of the watershed is 219.86 square kilometers. Latitude is 21 degrees 17 minutes 30 seconds, 21 degrees 29 minutes 12 seconds north. Longitude is 78 degrees 30 minutes 00 seconds and 78 degrees 59 minutes 15 seconds east. The category of the watershed is critical. The overall dendritic drainage pattern is dendritic and the rainfall is 975.8 millimeter per year and flowering close to 43 villages. The methodology adopted as hydrogeological survey using proportions of survey of India 1:50,000 scale, preparation of the geological map on the basis of field observations and existing data with the help of GIS tools, preparation of the geomorphological and drainage maps on the basis of field observations and existing data with the help of the GIS tools. Then the very inventory of the dugways and the pattern to study the parameters, establishment of groundwater level monitoring stations for pre-monsoon and post-monsoon static water levels, and on the basis of geology and geomorphology, identification of artificial recharge measure. This is the geological map of the area, showing 7 flows. 7 flows are simple and 1 is the classified basalt of the Deccan upper vegetation lower Eocene age. This is the drainage map of the area. The area is mainly drained by the tributaries of the Jam River, which is a part of the Varda River basin. The overall drainage pattern is dendritic, where at some places we can see the linear drainage, which indicates the linear means presence of linear means. There are some water bodies also in the area. This is the geomorphology map of the area. The geomorphology map of the area shows 7 peculiar structures, that is the mesa, buttes, escarpment, slopes, then the moderately dissected plateau, the slightly dissected plateau, the undissected plateau, and the weathered shallow zone. This is the village map and I have fixed some observation wells. Yet 100% of the area I have yet not covered. This is my first year of the PhD. Hydrogeology of the area, the secondary porosity developed by weathering of hard rocks and porous zones in the area facilitates the storage of groundwater. Aquifers are also influenced by joint sand fractures in the area. The average static water levels in post-monsoon ranges between 2 to 20 meters BGL, and in pre-monsoon it varies between 5 to 20 meters. The pre-monsoon and post-monsoon water level fluctuations range between 3 to 6 meter to 2 to 6 meter respectively, and the post-monsoon and the pre-monsoon average yield of the dug wells range in between 60 to 100 cubic meter per day to 18 to 50 cubic meter per day respectively. Significance of artificial recharge. It is very important to maintain or augment the natural groundwater as an economic resource to coordinate the operation of surface and groundwater reservoirs, to combat the adverse conditions such as progressive lowering of groundwater levels, to reduce or stop significant land subsidence, and to provide a localized subsurface distribution system for the existing wells to prevent surface runoff and soil erosion, and the artificial recharge structures are cement plugs then the continuous control bites, then the percolation ponds, recharge shafts, the UGBs, rooftop rainwater harvesting structures, etc. In all, the different artificial recharge structures are site-specific and hence can be identified by conducting a combined field survey of the study of geology, geomorphology and hydrogeology. This is the map showing the existing and the proposed structures in the watershed. As I have told you that I have not covered the whole of the area, I have covered some of it. The green structures are proposed and the pink and the yellow colored structures are already existing over there. Much of my fieldwork is yet to be completed. These are the structures proposed. Recommendation and conclusion. The analysis of central part of the WRJ2 watershed of Nagpur district on the basis of hydrogeology along with field and geological field checks lead towards the following conclusion that the main hydrogeological unit of WRJ2 watershed is Deccan Trap, which comprises different lava flows, and it's observed that the central part of the WRJ2 watershed is covered by vesicular and fractured massive basalt. Based on this geological aspect, sites for the CNBs, recharge shafts, UGBs, rooftop rainwater harvesting and population tanks are selected where sufficient thickness of weathered basalt was available to recharge the surplus surface water available. The proposed structure are suggested on a ridge-to-valley-based concept to treat the WRJ2 watershed. And as I have told you that the measures are site-specific and they are thus expected to derive maximum impact. These are my references. And I thank the Indian Science Congress, the Postgraduate Department of Geology, Nagpur University, Nagpur, and Groundwater Service and Development Agency. Thank you, sir.
Session is open for discussion. Any questions?
Madam, you have just shown that you are taking the help of the GIS also for this study. But I have not seen any geological map of the area, land use, land cover map of the area.
So I have not prepared the land use land cover, I have prepared the geological map and digitized the topo sheet of from the topo sheet, the watershed area. The drainage map indicates that, sir. The map should be prepared using GIS only, sir.
The topic of paper is identification of suitable sites.
Yes, sir.
So what sites you identified? What are the sites in WRJ watershed?
Sir, I have not covered the whole area. I have covered some part, and on my field basis, I have suggested some structures, sir.
What is the criteria for suggesting this?
So these are the green, the circular green patches, the circular green structure. They are the recharge shafts which I have proposed. And here there are the existing structures, and here some of there are water supply well of some of the villages. So that's why I have proposed here some recharge shafts, sir.
How many reserves are?
Total almost 50, sir.
50. How
Not
much
more than
economics?
that.
How much money it will consume?
Sir, I can't get it. Sorry, sir.
So the economics of constructing research shafts should also be worked out. Yeah?
Yes, sir. Yes, sir.
And these are your proposed site, these green lines?
Yes, sir. That is the hilly
11
area.
structure. 11.
Those are the hilly areas, sir. And I have proposed the CCTs, the continuous contour trenches. That is the hilly area, sir. Yes, sir. The gradients I have proposed in the first order drainage, sir.
What is the major river? Which is the major, this one? Major
Sir,
drain?
it is actually the tributaries of the Jam river. There is no such main river here. That is the fourth order drainage we can see, this big one.
And the reservoir?
Pardon, sir?
The reservoir?
Yes, sir, it is a natural reservoir. These are the water, different water bodies, so natural water bodies.
So actually, what is the honest told na?
Yes, sir.
Slope map of the area is required. Slope map,
Okay, sir.
gradient,
Okay, sir.
etc. This is all things are required.
Okay, sir, I will incorporate it, sir. Thank you for your suggestions.
Okay.
All these are natural water bodies?
Yes, sir, these are natural. These are digitized.
So what about the water status is for whole year water is there?
No, sir, this particularly this area is orange and citrus cultivation dominantly. So the all the means in summer the area faces the severe scarcity, sir, due to the over exploitation due to the citrus and orange cultivations, sir.
Thank you.
Thank you so much.
I'm Rashtrasant Tukadoji within active of Tukadoji area between Northeastern region Assam, India, and its genetic significance. This particular topic covered in the presentation. We can have a brief introduction, then geology and mode of occurrence, then neurological studies, then X-ray diffraction studies, scanning electromagnetic studies, EPM studies, and then genesis of lomotite. Basically, lomotite is hydrous calcium aluminum silicate mineral of geolite. As we know, geolites are secondary minerals mostly found in Deccan Trap or basalts. But apart from Deccan Trap, it can occur in variety of other igneous rocks, sedimentary and metamorphic rocks. So, this mineral is found in amphibole by drilling for iron ore investigation, and this was the mineral found in Britain by Gillette Lomot in 1785. This is the regional geological map of area. This area generally comprises of rocks of Assam, Meghalaya and Nicene complex that comprises of biotite plains, pegmatites, then melted iron formations and granite gneisses, different varieties, photolite, fungible gneisses like that, and then Shillong group of rocks. That means Shillong Basin comprises of Shillong group of rocks in the form of sedimentary rocks, metasedimentary as well as volcanic sedimentary rocks, and then in the include granites, that is porphyritic and non-porphyritic granites of non-porous, and then exclusive rocks of select tribes. That is some part basaltic dust and then some are violet, andesite like that. And then last quaternary sediments. But it also have a lot of fault pattern systems. In the northern part you can have Brahmaputra fault system, in the southern part you can have Dharti fault system, and then northeastern part you can have Populi fracture or Populi, and right side got Nigris, that is mostly granite hills, and apart from you can have long-term part, that is along that long-term part lot of alkaline rocks, laprophytes are yes. And then main shear is Badamani shear, that is almost northeast southwest passing from Shillong. And then one more is there is a lineament, that is Unnaganmukh lineament. And apart from this, all this fracture system, the main study area is comprises of small isolated Inselberger hillocks of Mediterranean formation basically, and where the drilling for iron ore investigation was carried out. During time, we have reported this lomotite in amphibole, but on surface mapping or large scale mapping, we have also reported this small mafic alternative suite of rocks. We can have this amphibole, then peridotite, then gabbros and dolerites, and then these quaternary sediments of Chapar, Hori and Barpeta formations. This lomotite occurring this boron number DCB16 in form of veins and along fractures. But you consider the graphical lethal of this boron number DCB16, it is total 61.5 meter, and this BI is under 2238. But this lomotite veins occur within amphibole at 43 meter depth up to 65 wide, and in between larger well is 7 meter around. This is the pictures of linotype in 4 samples. You can have this continuous linotype wind, and in central part you can have small white color calcite base. This either side is bordered by linotypes. And this is the host angular rock. This also contain garnet. This garnet also occur in different forms, having some deformation in the host rock. This is a different fact in linotypes in photography. It also has calcite in central part, and then this linotype on either side. But one interesting feature in linotype is that this radiating crystals are inverse, pointing inwards towards calcite. That shows the crystallization or growth from margin to centers. And this is contact between this linotype calcite veins and host ampullite. This ampullite along with plagiaries, epidote, garnet, and epidote. If you consider garnet, it has very different shapes and size. You can have almost hexagonal to somewhere tetrahedral, and another grace forms continue chain-like feature along some deformation. And this Roman type also have some co-folding along with most rock. This is the X-ray diffraction analysis study. In XRD also we have confirmed this Roman type is neither neutral. Apart from this Roman type, calcite is minor. Also ACM studies, we can have morphological studies, calcite, Roman type, and angular. But when we analyze the EPM studies of this geological Roman type, silica is not even 59 to 68%, relatively high compared to geolite. Then calcium 8.5 to 8.9, and aluminium 13.01 to 14.7. And on the basis of these elements, we have plotted this triangular diagram. So this mineral is plotted in the calcium with A members in long-term phase. So overall studies, as you know, secondary minerals, fluorides, occur in basalts and generally found in temperature of 60 to 200 degrees centigrade temperature. And in particular, linotype is nearly around 100 degrees centigrade temperature. And one more is that calcium with plagiaries. Utilization of this plagiaries occur that enters the calcium solution, and that also in interaction with the saturation and in interaction with the country drops, that can be linotype also can be formed. And this autothermal solution then along with the planes or fracture zones or joint that can be impressed, and then that can simultaneous recrystallization and precipitation help to form the linotype. Overall our field studies, combined petrography and mineral chemistry, all of that this linotype is part of hydrothermal solution that might have generated as we see in geological map. There are a lot of Brahmaputra faults, and this area just in the northern bank of Brahmaputra, just hardly you can see 200 meters from Brahmaputra bank. So this could be the generation of calcium hydrothermal solution that is responsible for formation of this linotype mineral. Thank you. And this is that where drilling for iron ore was carried out. In that particular border, we got that place of problem.
So what is the economic use of this mineral?
So this is the geolite group of mineral. So adsorbent and your water filters, this can be used. This is just like other geolite group of mineral, more than 110 geolite minerals are there. But this is the unique mineral, it won't get everywhere. Even our Deccan basalt, Maharashtra, hardly 3 to 4 locations are there for linotype. Otherwise, you can have other steel bites, like other minerals.
Because geolite is used for the gem purpose also, very high cost in this.
Gems, so they depend on but generally the geolite won't be used for gem purpose. I have this probably we can use for saving this.
Gem is decorative.
That is decorative, only this decorative. But industry use that for also for management of radioactive waste. They use this two geolites.
Discussion, any other question?
Moreover, there may be no commercial exploitation will not be there, because it's just whatever you find out in the borehole and others, this has to be come into production and recovery of the mineral from
it is not possible. So it is just in the vein. We have explored for iron ore basically, and in that iron ore, just limit was 25 to 30 meters per day. Surface road. But while we intersected this mineral, so we have taken permission to at least we allowed to go at least some 30 meters. So that's why that mineral we are forming.
Any shear zone is there?
The fault system is there, sir. Some of the fault system is there. That's why. And even subsurface there are Dubri fault is there. So long back when earthquake was there in Assam, so that is reactivated that fault, Dubri fault system.
And it offers confined to amphiborates only.
This mineral is confined to amphiborates.
But in the model mineralogy it is not reflected. I have not seen that model mineralogy. No? So with this H, GRH. It is no zeolite is there.
These are host rock minerals. Basically this is for host rock and this is for
occurring as veins.
Veins. Along the veins of the water. This is an ACM study. This is and this is for host rock. I have also analyzed host rock mineralogy, but I have not
Definitely secondary.
Okay, any questions?
Thank you.
Metrological and core mineralogical studies is Sapoli Gold Belt.
Good afternoon to all. I'm welcoming you all in this session. I'm presenting a technological and organizational study of Sapoli Gold Belt, Central India. This is my research work, and I'm doing my research from Department of Geology, Nagpur University. This is the area. Actually, you all know Sapoli Gold Belt is very well known for its mineral belt, entirely in Central India and district of Maharashtra. The arcing paleoprogenic transition of rocks of Sapoli area, Central India, of the influences on interrelated tectonic crustal evolutionary cycle with multiple metallurgical evolutionary units spread over area in space and time. This is the actually geological map of the area, where mainly it has given in 1995 Roy and Ekman. They have proposed the four-fold classification and they divide the Sapoli in four groups: lowermost Arctic formation, Trappetic formation, and Rockic formation. Mainly this area is part of Western Western Pattern. This Western Western Pattern is arcing. This orcas arcing rock means Amla and Sukma litholamine is forming the basement for this Sapoli area. Here mostly Arctic formation is this, and then Trappetic formation and then Rockic formations. It's included with Plenary pigmentites phosphate. This study pigment contact with amylose, which are only the synthetic context. I have carried out the study in the area from Argentina to Kanda area and from Finland to Sangan area. Here I have carried out more than 100 locations visited and pathological samples was taken to 70, and then few studies I have did and out of that few studies I have find some different food localities where I got some typical significance which are contradicting earlier geological workers, mainly global formation, which they have reported as metal halides, metal basic, all excellent rocks. They have now here you will find some different contrasting observations from my side. These are the four observations. This rhyolite showing this in the Bivapur formation, this first location. Then second location we will discuss. Then third and fourth. The first locations. It is the field observations. This is rhyolite rock, which showing harmonic quartz ring on line on the surface, and this adjacent area. This
Sabra open cast mine area, Tambekhani, North Pada, and this is adjacent area which is just 1 kilometer less than 1 kilometer. The rock, contrasting rock means here are the basic rocks, basic volcanic rocks, and here are the rhyolite, which are also volcanic rocks. And further in the next year, I am showing the closer exposure observation, exposure basic observation on this spot. This is copper sulfide dispersion on the rhyolite, and this powder material is also here, and this is just addition of that stringent type of dispersion of maybe sulfide. Actually, I have studied sulfide are there, mostly coppers. This is totally igneous looking, and also it find out as igneous rock, and this powdery white material is something different minerals which formed during the coming of ore mineralization. Actually, that was found in rocks. Because of that, I cannot observe closely very good way in thin section, and then I go for XRD analysis. When XRD analysis, both the samples are given for XRD analysis, where quartz find out 95% chalcopyrite, which you have already shown that nuggets which are impacted that outcome, chalcopyrite, this in percentage all. And in second part, quartz 63%, clinochlor, clinochlor 25%, biotite 10%, chalcopyrite 2%. It is purely the acid volcanic rocks. And this composition of 25% and 10% is indicating the genesis of clinochlor mineral is due to the magmatic origin, not the metamorphic origin. And this is the product of deuteric alteration. Deuteric means the volatile material that is dissolved during the magnetic process. And this rock form when the rock crystallizes, it's altered by its own late fluid fraction, which trapped within that own formation, and amorphous type of compound that are formed at the end of crystallization, and that fill in interstices places, and when that places, that means was also containing that minerals. Then this is the ore sections of same area. There are various different copper minerals means cobalt, chalcopyrite, and goldnites, which I have observed and at this area that arsenopyrite, pyrrhotite, and pentylite I have observed. After EPMA and other study, I will find out some other goldnite associated mineralization, because that abundant mine, what first photograph shown, that was closed due to the 0.6 ppm content of gold in their waste product. And these are the three mineral different phases I have found in that same area. With Tambekhani area on surface oxidized vein, near oxidized vein, where the different minerals means arsenopyrite, pyrite, chalcopyrite, and other mineral bornites I have find out here. Here also this is different phase. Here I have find out pyrite, bornite, arsenopyrite, chalcopyrite, 3-4 phases in single location. This second site, which are in the Keshavara, means that is away from this place, in the core part of my study area. These sites, when I go on to the field, I have found basaltic rocks. The very vast hill was there. I cannot climb out on further side. Because of that, I came back, and then I found this this type of agglomeratic type of mineralization, and even pillow type of basaltic concept. Then further I came down, then I find out this vitreous structure, basic rocks. Initially I was not knowing what is this. Then again I have find out this with addition to that, and that when I have find out this radiating textures I find, but I cannot guess what was there. After petrographic study and this needle shape spin peak textures, which these are the olivine and other
hydrous region, means hydrothermal solution may gone up to that level. Because of that, this alterations of and termination of this minerals is showing here. This is also alteration of then this rock what just this all area I am showing it is only just 500 meter length on surface. This is typically I first observed I was considering this was the basalt, but after petrographic study I came to know this is the original comatite rocks, which this textures is further I have observed in enhanced magnification. These are showing comatite texture, specifically hydrous comatite textures, and this laboratory plate forming within the melt of water. And after this, I have observed in transmitted light. That time, I found this mineral and various 3 pages of impregnated minerals, which was in that comatite rock, which I have shown earlier. This very stated further I have to find out what could be it, what could be possibility of this. Because of the structure I cannot say it is comatite rock. Because of that I searched and studied detailedly that textures. Then also I have submitted this sample for XRD analysis, and in XRD analysis mainly phyllite and gabbronorite minerals I have found. And this phyllite is the iron rich end member of all in solid solution series, and labradorite is also the end member, but it is the first member of feldspar series. And this has triggered, this has created the opportunity to impregnate the mineralizing fluid within itself while transmitting from lower mantle, deep mantle to up to the crust. This is third locations which are in diaphragm formation. This is Copa region forest area where this rock is showing us the crisscross and inclusion of these spots. These spots means containing the gold mineralization which are very well reported, and this area also gone for exploration. This is containing 12% of 12 ppm of gold in that area. This is also the veins at adjacent area which containing internal reflection, and gold is also reported in this area. Samples are submitted. After further study, I will conclude for that part. This is last location. Here also the primary magnetite deposits along with various minerals, means pyrite, chalcopyrite. This is zone pyrites. All the 3 phases of minerals along with magnetite I am getting there in that area. It is mainly primary iron depositions. This area also shows the path of ore fluid mineralization intrusions. These are the older granites. It is located in this area below Luckney, and these both are sampled from this area where this opaque colors and opaque spindles are the hydrothermal fluid which are travels from their origin source rock up to the country rock, and this is migration path. And by concluding all locations and a study of this area, I have saying the hydrothermal mineralizations in Sapoli area is inextricably linked with volcanism, because acid volcanisms in the north of the Adal Plains I have found out. Then I came to in the Kesalwara area, that also comatite mineralization, basic rocks I get with mineralizations. And then after the third location and fourth location, granite, and older granite and vein granites and vein type, phosphate types of mineralization, which are all mineralization that indicating plutonic hydrothermal events. And for this area, I have suggested the volcano-plutonic to subvolcanic and volcanic related magmatic meteoritic hydrothermal systems, which are associated with the rifting of the area. And because of that, this point of view, nobody has studied like this, and I am further studying this. This is my part of the study. Partly I have studied, not completed, and various other I have come to know with the findings with ultra basic hybrid volcanic rocks, presence of volcanic rocks, which are the new addition from my side. And this is a fluoride.
Time is over.
Thank you, sir. I am thanking the Department of Geology, my guide, for providing me this opportunity in the platform of this 108 Science Congress, and then all my fellow colleagues who supported me, Dr. Nagpur sir, for allowing me to accept my request. Thank you, sir.
Session is open for discussion.
No, I have a question. Actually, you have just put up this whatever the petrographic study is a tool. So my query is whether there is some previous work has been not done, whatever the finding you have made, discovery of pyrite, gold, and other things.
Yes, sir.
A lot of paper has been published on this. A lot of work is done. So how we are correlating your work is something?
Yes, actually, sir, they have did, but the area what I have shown committed area, nobody has touched that area. Actually, means I have gone by walking with 7 kilometer, approximately 6 to 7 kilometer area there. They have walked by Mahapatra and Iktisaha, and they have got the mineral hour for the gold finding. But nobody has touched that area. That area is very this area is this area is very thickly forested area, and that falling tiger patch, tiger reserve forest patch. Because of that, nobody has entered in particular in this area. What I have shown, and that Kamikani area, there a lot of work has done, and they have said that means rhyolite is a meteorite because of presence of fluoride minerals. I have shown fluoride mineral. The genesis of fluoride is from igneous magmatic crystallization.
No, what sir is telling, you also refer to the old literature,
Yes,
whatever
sir.
literature is available.
Literature
and you
is not available.
and you align your study according to that literature.
Sir.
Yeah, other literature are there are several publications. Then
Yeah,
about
yes, sir.
publications on sapphire. So you read all the literature and align your focus on that.
I have read, sir, lot of literature I have read, and yes, I itself come in conclusion that there are means Catholic formation is younger, Vivapur formation is older. They have, we are doing mapping. Even from last 2019, it is. Sir, may have come, you may have come for MDR and all this. They are all CSI is reworking on that stratigraphic and mineralizations. Some has carried out metamorphic mineralization in that area. They have in Goldman research. She has Dr. Pamita Pal has shown their fluoride appearance and formation, and they have shown the hydrothermal origin of fluoride as well as kyanite selenite also.
Okay. Okay, Dada, you study all this and then report come with certain more focused conclusions. Okay?
Yes, sir. Conclusion is more miss.
Thank you.
Yes.
Okay. You read all the documents, all the papers, and then there is no presentation, but it is requested by Sri Anil Kumar from Patna. He is going to present this.
मेरा संबंध भूगोल से है, मेरा पेपर भूगोल से। पटना जिला बिहार से मैं संबंध रखता हूँ और पटना जिला के ही एक छोटा सा भौतिक इकाई है जो बाढ़ ग्रसित है। प्रोफेसर पी दयाल ने उसको सेपरेट भौतिक इकाई के रूप में मान्यता दी है अपने पीएचडी में, जो कि लंदन में 1948 में प्रस्तुत हुई थी प्रोफेसर डाटले अष्टम के सुपरविजन में। तो मोकामा टाल में आहर और पई, मैं यहाँ स्पष्ट कर दूं कि नदियां जब बहती है तो अपने आसपास अवनलिका बना देती है, बहाव क्षेत्र छोटे छोटे बना देती है। उसमें जो बड़े बहाव होते हैं उसको आहर बोलते हैं, जो छोटे बहाव होते हैं, दरिया होते हैं, उसको पैन बोलते हैं लोकल भाषा में। आहर और पैन का क्या रोल हो सकता है मोकामा टाल के सिंचाई में, इसी पर मेरा पेपर है। मोकामा टाल नदियों का क्षेत्र है। महाने, जिसका कि ऊपरी हिस्सा खड़गू के नाम से जाना जाता है, उससे भी ऊपरी हिस्सा छोटानागपुर के पठार पे लोहान के नाम से जाना जाता है। उसी का ही कुछ और पार्ट है। चूंकि ढाल प्रवणता बहुत कम है, इसी चलते एक ही नदियां कई भागों में बंटकर बहती हैं। समुद्र तल से इसकी ऊंचाई 35-36 मीटर है। तो खेदू पोखर, धनाई, महाने, ये 3 प्रमुख नदियां बहती है, जो त्रिमुहान गांव के पास एक आधार तल को प्राप्त कर लेती है और वहां पर एक नए आधार तल के साथ एक नदी का जन्म होता, जिसका नाम है हड़ुहर, जो कि लखीसराय के बलाबुद्दर गांव के पास गंगा के मुख्य प्रवाह तक जाती है। समूचा दक्षिणी बिहार का जो पश्चिमी हिस्सा है, पूरा जल इसी क्षेत्र से होकर गुजरता है और इस क्षेत्र की संरचना तस्तरी नुमा। इसके चारों किनारे पर ढाल ऊंचा है और बीच का भाग अपेक्षाकृत गहरा है। दो नेचुरल तरीके से यह क्षेत्र फ्लडेड बन जाता है। यहाँ पर मैं ये कहना चाहता हूँ कि जल जमाव की स्थिति का निदान भी हो जाए और आहर और पानी का प्रयोग भी हो जाए इरिगेशन में वर्षा ऋतु के बाद के समय में। तो इसमें विश्लेषण में एक कहा गया है कि आहर और पानी जो नेचुरल बनावट है, उसके अलावा उस प्रधानमंत्री ग्राम सड़क योजना से जो मिट्टी की खनाई हुई, तो कई कृत्रिम आहर पैन नुमा बनावट बन गई। तो नेचुरल बनावट और कृत्रिम बने आहर पैन नुमा बनावट को अगर मिला दिया जाए और उसका कनेक्शन महाने से होते हुए हड़ुहर तक कर दिया जाए, तो यहाँ पर वर्षा ऋतु के बाद, हथिया नक्षत्र के बाद बहुत विशाल मात्रा में पानी का संग्रह कर सकते हैं, जो कि हमें अप्रैल माह तक चलेगा और हमारे भूमि भी रिचार्ज होंगे नेचुरल तरीके से। हालांकि इतने फ्लड आते हैं कि भूमि रिचार्ज का कोई मकसद रह नहीं जाता है, फिर भी भूमि रिचार्ज होंगे नेचुरल तरीके से। भूमि रिचार्ज होंगे तो जाहिर सी बात है भूमिगत जल जो बहुत बहुमूल्य जल होता है, उसका दोहन भी कम हो सकेगा। तो इसी में चर्चा है इस आर्टिकल में कि आहर और पैन को, जैसे भारत सरकार की अमृत योजना है, नदियों को मिलाने की योजना, जहां तक पॉसिबल हो सके जो नदी को मिलाया जा सके उसको मिला दिया जाए। केन और बेतवा पर काम चला सबसे पहले, तो ये उसी रूप में यहां भी किया जाए। भारत बिहार सरकार की भी विशेषकर 2008 के बाद कृषि कैबिनेट का गठन हुआ। मैं जरा सा इसको स्पष्ट कर दूं कि कृषि कैबिनेट है क्या। बिहार कृषि संसाधन प्रदेश है, कृषि को बढ़ावा देने के लिए वर्तमान सरकार ने 2008 से 2005 से ही चल रही है सरकार, गवर्नमेंट वित्त विभाग, जल संसाधन विभाग, कृषि विभाग जैसे 12 विभाग को एक जगह ऑर्गेनाइज करके एक आयोग नुमा पॉलिसी बनाया, जिसको कृषि कैबिनेट कहा गया। उसके पॉलिसी को कृषि रोड मैप कहा गया। प्रारंभ के तीन कृषि रोड मैप का लोकार्पण, 2 कृषि मैप का लोकार्पण वहां के राज्यपाल किए। तीसरा कृषि रोड मैप का लोकार्पण जो 5 वर्ष का कृषि रोड मैप होता है, पॉलिसी होता है, 17 से 22 जो हुआ उसका राष्ट्रपति कोविंद साहब ने किया था। चौथा कृषि रोड मैप बन चुकी है जो 1 अप्रैल को लोकार्पित होगी। पता नहीं है कौन लोकार्पण करेगा। तो कृषि रोड मैप का चौथा जो डायमेंशन है उसमें कहा गया है, मैं यहां ये स्पष्ट कर दूं कि कृषि नीति से, कृषि रोड मैप से बिहार में लगभग 22 से 24% उत्पादकता बढ़ गई है, क्योंकि सिंचाई के चलते फसल की उत्पादकता 6 गुनी तक बढ़ जाती है। प्रोफेसर रंधवा मिट्टी वैज्ञानिक का कहना है। तो 22 से 24% बढ़ गई है। तो चौथा कृषि मैप लिटरेचर बनाते बनाते एक बैग आया रिपोर्ट सीएम साहब का 25 दिसंबर, नहीं कोई बात नहीं, हो जाएगा, कोई बात नहीं हो जाएगा। ऐसे भी अब जूरी के सधे गुरु बैठे हैं, अब उचित नहीं हुआ उतना मेंटेन कर लेते हैं। तो 25 दिसंबर को सीएम का आया कि चौथा कृषि मैप कृषि के आधुनिकता की ओर समर्पित होगा। 2020 में बिहार सरकार की एक नीति जो सिंचाई को समर्पित थी, पर्यावरण को समर्पित थी, पानी देना दीदी, पानी, जल जीवन हरियाली, जल जीवन हरियाली बिहार गवर्नमेंट की नीति है। जल मतलब जल को सेव करना, जल को उचित प्रयोग करना और सिंचाई के लिए हर खेत को पानी देना, ये मैनिफेस्टो में है गवर्नमेंट के।
सर आपसे थोड़ा अपने कंक्लूजन पे आएंगे।
जी। तो हम ये कहते हैं कि जल जीवन हरियाली के तहत, ये उसी प्रोग्राम के तहत आहर और पैन को, चूंकि गाद एरिया है, मलबा वहां जमा हो जाता है, विशेषकर फरक्का बन जाने के कारण, फरक्का डैम बन जाने का कारण गंगा के प्रवाह को पूरी तरह विचलित कर देता है फरक्का। तो जाहिर सी बात है, जब नदी का प्रवाह 2 गुनी कम हो जाएगी तो उसके गाद ढोने की क्षमता 64 गुनी कम हो जाती है। तो गाद धोने का जो नेचुरल फ्लो है प्रभावित होता है फरक्का के चलते, और इसी चलते बिहार और यूपी में बाढ़ आता है। ठीक है, बांग्लादेश बच गया, बंगाल बच रहा, लेकिन बिहार डिस्टर्ब हो गया, कहीं बचा तो कहीं डिस्टर्ब हो गया। तो जल जीवन हरियाली के तहत जो आहर और पैन में मलबा जमा हो जाता है, उसको प्रत्येक वर्ष उड़ाही करके, मैंने उसको सफाई करके गहरा कर दिया है, और छोटे छोटे एकदम लघु छोटे छोटे चेक डैम बना दिया जाए, ताकि जल आए भी और ओवरफ्लो होने के बाद जल चला भी जाए गंगा के मुख प्रवाह में, और जल संग्रहित भी रहे। बस इसी पर मेनली फोकस किया गया है। कुछ पॉलिसी है, कुछ निर्माण है, जैसे कि मोकामा टाल में 187 करोड़ के लागत से एंटी बाढ़ स्लुइस गेट बना, उसकी चर्चा की गई है। 5वां गेट भी निर्माणाधीन है, अप्रैल तक निर्माण हो जाएगा। कुछ सोता की लंगड़ी सोता की चर्चा की गई है। सोता मतलब मीन्स आहर पैड, क्षेत्रीय भाषा में उसको सोता भी कहते हैं। तो यही है और धन्यवाद सर। मैं लो विजन के समूह हम क्षमा चाहते हैं कि हम पीपीटी नहीं दे पाए। जी सर, वो मेरी दीदी है, वो सहायक इसके ऑथर हुई इस पेपर की। जी
धन्यवाद।
D. Fuller. D. is going to speak here on sustainable. A sustainable participatory watershed development in Rodana. Please.
Good afternoon, dignitaries, faculty member and dear student. I am Apurva Puladi from PG Department of Geology, Nagpur University, Nagpur. I warm welcome to all of you. My today's presentation topic is a sustainable approach to participatory watershed development in the Dodna mini watershed using remote sensing and GIS technique. I would like to overview about the study area, geology, geomorphology, hydrogeology, watershed management, recommendation, conclusion and references. First, let's begin with introduction. Groundwater is a valuable and essential resource which forms the basis of all economic activity ranging from agriculture to industry. The safe groundwater abstraction and proper groundwater management is important for the sustainability of this precious resource. The optimum management of these resources with minimum adverse environmental impact is essential not only for the sustainable development but also for human survival. In participatory watershed management, participation of local people is necessary to identify and priorities need-based problems, select technology and policies and monitor and evaluate impact which will improve the performance. Effective groundwater management in any watershed or basin is purely based on the fact that how best one understand the natural environment in which groundwater occur and moves. The northeast part of Amravati district, Maharashtra, is facing severe overexploitation of the groundwater for orange cultivation from shallow as well as from deeper aquifer, especially Varud, Morshi, Chandurbaja Tehsil, resulted in depleting the groundwater level. Sustainable development of any region is based on the optimum utilization and rational development of natural resources, including groundwater. Scientists Krikandia demonstrate the success of watershed management in Radegan Siddhi village of Ahmednagar district, Maharashtra, which include people participation and construction of artificial groundwater recharge structure. Many areas of the study region are affected by overexploitation and depletion of groundwater resources because they are underlain by hard rock aquifer with limited storage potential. Due to the overexploitation of groundwater, especially for orange cultivation from shallow as well as from deeper aquifer of Varud and Morshi Tehsil of Amravati district, Maharashtra, resulted in severe depletion in groundwater levels. The Dodna mini watershed is also declared as overexploitation due to excessive withdrawal of groundwater for irrigation. Artificial groundwater recharge is one of the most effective groundwater management strategies for maintaining groundwater resource sustainability. Participatory watershed management has emerged as a new approach for planning, development, management of natural resources with concentration on social, economic and environmental aspects. The objective of the proposed investigation are as to study the groundwater availability within the basin, to study the area suitable for groundwater recharge within the watershed, and to prepare water conservation and management plan for the study area. The study area is a part of Murshi Tehsil of Amravati district, Maharashtra state, and is a part of Wardha river basin. This is the location map of the study area. Then move to the methodology. The methodology adapted for the study include consideration of the satellite data, which was georeference using topo sheet 55G/16 of the Survey of India. The topographical and geological maps were geo-rectified using spatial analysis technique. Satellite data provide fixed and useful baseline information on geology, geomorphology, land use, land cover and soil, and other features of the terrain which control the groundwater occurrence, distribution and movement, and leads to better delineation of groundwater potential zone and scope for constructing artificial recharge structure. This is the flow chart which shows the hydrogeological investigation of the Dodna mini watershed. Then geology of the area. Stratigraphically, the basalt lava flow of this area are included in the Sahyadri group, and this watershed, the geology of the area is categorized as Karanza and Ripur formation, and the age of the Deccan basalt is upper Cretaceous to lower Eocene. Then geomorphology of the Dodna mini watershed. The geomorphic unit exposed in the mini watershed are gullied land, pediment, pediplain and water body, that is pond. This is the geomorphological map of the study area. Then this is the land use and land cover map of the Dodna mini watershed. The land use and land cover study indicates that agriculture is the main activity through the basin, whereas some part of the basin mostly occupied by forest, barren land, build-up land, water bodies, etc. Then moves to the hydrogeology of the area. Basaltic lava flow are the most common rock formation in this watershed. Static water level in pre-monsoon season of the Dugville ranges between 5 meter below groundwater level to 10.67 meter below groundwater level. The seasonal water level fluctuation in the study area ranges between 2 to 7.93 meter below groundwater level, and pre-monsoon yield of the Dugville ranges between 4,500 liter per day to 1,97,100 liter per day. Basaltic layer encountered in the drill well section during hydrogeological field work include highly weathered basalt, moderately weathered basalt, vesicular basalt and compact massive basalt. This is the well location map of the study area. The hydrogeological field observation of the study area comprises different villages of the wells like Maniyardi villages, Charor, Ashtega, Bhangara, Malkapur, Ambada, Borana, Kopra villages. This is the yield map of the Dugville in Dodna mini watershed. Yield of the well can be determined on the basis of capacity of the pump and pumping hour. Pre-monsoon yield of the well ranges between 4,500 to 1,97,100 liter per hours in fracture, weathered and vesicular, spheroidal and amygdaloidal basalts. This is the graph which shows variation of yield of the well with respect to the land use, land cover. This map shows the existing and proposed water conservation structure of the study area. By considering the hydrogeological condition and available runoff, the suitable artificial groundwater recharge structure are recommended for the Dodna mini watershed, which are cement lug, gabion structure, etc. This is the field photograph for collection of well inventory data and also different water conservation structure of the study area. This is a dugwell, open dugwell in the study area in Ardhamani village, Amravati district, Maharashtra. Second image shows the fracture basalt. Third image shows the third image shows the open dugwell in field of Prashant Ingle in Bhangara village, Amravati district. And next image shows the photograph 4, which shows the Mamdapur village. And photograph 5, dugwell in front of Patkar in Bhangara village, Amravati district, Maharashtra, and photograph 6, which shows Ardhamani Talab near Pimpri village, Amravati district, Maharashtra. And lastly, we move to the conclusion. The study area was covered by thick orange cultivation. Also, the area falls under the assured rainfall zone and had good hydrogeological potential, but due to excessive withdrawal of the groundwater and unplanned irrigation system, this area is declared as a overexploited. The integrated approach using thematic information obtained on the basis of remote sensing imagery and data obtained during hydrogeological fieldwork are utilized to derive following conclusion for the study area. The geomorphic units like pediment, pediplain and gullied land has good groundwater potential. The study area are favorable for groundwater storage by virtue of thick weather mantle, presence of primary porosity as well as secondary porosity in terms of joints and fracture. The land cover pattern of the area reveals that 49.96% of the area is under agricultural activity of either rainwater or groundwater within the mini watershed. In the study area, the weathered, jointed and fractured basalt, which are principally recharged by a lateral force from the direction of unusual rainfall and local reservoir, and the study area is favorable for groundwater development due to assure rainfall, favorable geology and geomorphology. And also, community needs to be aware about importance of groundwater availability, causes of overexploitation and sustainable use of groundwater resources, and strategy for management of groundwater resources including supply and demand side intervention are necessary, which should be adapted in systematic and scientific manner. On the basis of present research work, recommendation for the study area are as conjunctive use of the water by considering the hydrogeological condition and available runoff. The suitable artificial groundwater recharge structure are recommended for the Dorna mini watershed, which are cement plug and galvanized structure. And also further scope for constructing artificial recharge structure like farm pond, percolation tank, underground bandhana, and it is also favorable for soil conservation as well as water conservation, and it is the study area also used for drip irrigation system and micro irrigation system for orange orchard should be adapted on priority basis. In the present case, storage zone of the watershed is favorable for groundwater development in the static water level in this zone are shallow and yield of the duck well ranges between 4,500 litre per day to 1,97,100 litre per day. And also public awareness must be created amongst farmers, and also land, water and soil management has proved to be very efficient method for sustainable agriculture, food and drinking water security. It is only through wholehearted participation of the community and stakeholders. This is the references. Thank you. Yes, sir.
You have explained so many conclusions, but no, my question is, in brief, can you able to explain what is participatory watershed development, in what way it is used during your studies? First explain what is participatory watershed development, and in what way you have used this during your studies.
The public awareness of the watershed management technique and water conservation technique वहाँ पर कैसे लाए ये अपन वहाँ पर पब्लिक को अवेयर कर सकते हैं।
आपने क्या किया? That's right.
सर हमने this is the proposed water conservation structure of the study.
No, he is asking you,
Yes.
whom did you, or with whom you shared your findings so that they can actually utilize, and then did you convince them?
Yes.
Because what happens in India, you may find scientifically anything, but traditionally whatever is believed will be accepted. जैसे आप मेडिकली उनको कहेंगे whether you will get a son or daughter is not possible, but traditionally हो सकता है उनको कोई वहाँ पे ज्योतिष होगा तो मेरे पास आओ मैं तुमको एक दवाई दूँगा जरूर रखा। So that kind of thing, did you face anything like that, or you have not done anything? You can just admit you have not done. There is no harm in that. You have not done.
Could you show the title of this paper?
Sustainable approach.
Take
Participatory watershed.
Sustainable participatory.
Sir, ask you,
what is participatory, what is development?
Participation of the people for control the soil erosion and also water.
Okay, thank you very much.
Okay, Ishida is there.
Good afternoon, everyone. My name is Ishadaya Nagpur. I am a research scholar in the postgraduate department of geology, Nagpur University, Nagpur. And today the topic of my presentation is study of the groundwater assessment of the critical watershed WRJ of Nagpur and Karton Tehsils of Nagpur district, Maharashtra state, India. The location map of my area. This is the general information of the area, which I told earlier also. The basin is the Vardha basin, sub-basin is the Jam River. The portions included are 55 K by 11 and 55 K by 7. Area of the watershed is 219.86 square kilometer. Latitude is 21 degrees 17 minutes 30 seconds to 21 degrees 29 minutes 00 seconds north, and longitude is 17 degrees 30 minutes 00 seconds, 17 degrees 59 minutes 15 seconds east. Category of the watershed is critical. Drainage pattern is derivative, and a total of 43 villages are included in the area. This is the village map and observation well map of the area WRJ2 watershed. This is the geological map of the area. Total 8 lava flows are there. 7 are simple basaltic lava flows, and 1 is the unclassified basalt. And the age is the upper Cretaceous to lower Eocene age. This is the drainage map of the area. The area is mainly drained by the tributaries of the Jam River, which is a tributary of the Vardha river basin. The overall pattern of drainage is dendritic. The dendritic drainage pattern indicates that there is presence of hard rock in the area. This is technical. This is the geomorphological map of the area, which shows the presence of buttes, escarpment slopes, massas, moderately dissected plateau, slightly dissected plateau, or shallow weathered zone. The hydrogeology of the area, the secondary porosity developed by weathering of hard rocks and porous zones in the area facilitates the storage of groundwater. The aquifers are also influenced by joints and fractures in the area. The average static water levels in post-monsoon ranges between 2 to 15 meters below ground level, and pre-monsoon ranges between 5 to 20 meters below ground level. The pre-monsoon and post-monsoon water level fluctuations range between 2 to 6 meters and 2 to 4 meters respectively, and the post-monsoon and pre-monsoon average yield of the dug wells range between 60 to 100 cubic meter and 18 to 50 cubic meter per day respectively. For carrying out the groundwater assessment, the methodology adopted is as per described by the Groundwater Estimation Committee, Ministry of Water Resources, Central Government, which states that the stage of groundwater extraction, if it is less than or equal to 70% and the pre-monsoon and post-monsoon water level trend is rising, then the watershed falls under the safe category. That means there is scope for further groundwater development in the area. If the stage of extraction is between 70 to 90% and either one that is the pre-monsoon water level trend or the post-monsoon water level trend, either both of them are falling or rising, then the falling or rising, then the watershed falls under a critical category. Here also there is limited, there is no scope for further groundwater development, and if the stage of extraction is more than 100%, then there is literally no scope for further groundwater development. Here the farmers in the area, they don't get new wells in the different government schemes. Here digging of wells, sinking of wells and bore wells is totally banned in this area. Now what is the importance of groundwater assessment? To increase the increase in stage of groundwater extraction over years due to excessive withdrawal of groundwater for orange and other citrus crops poses the problem of severe scarcity of water in the area during summer. The groundwater assessment is very much useful to the planners, policy makers, farmers and other stakeholders. The assessment will be beneficial, particularly in drought management. The computation of groundwater assessment on annual basis only will be able to establish the relationship between the annual rainfall and the annual groundwater recharge. For conducting the groundwater assessment, we need data from the various government offices, and the data required is the rainfall data, land use data and cropping pattern data, which is necessary for estimating the spatial and temporal distribution of groundwater withdrawals. Then the canal data is required to calculate the seepage loss test, and also the wetted perimeter is required to calculate the capacity of the canal. Then the data of the tanks and existing tanks and ponds is required for computing the infiltration capacity to be used to evaluate the recharge from the area. Then the data of the water conservation structures are also required to calculate the total annual groundwater recharge by these structures. The data of the static water level, that is the pre-monsoon and the post-monsoon average static water levels are also required, and the aquifer, the data of the aquifer parameters like storage coefficient, transmissivity specifically are required. This is the groundwater assessment of my WRJ2 watershed done by GSDA and CGWB. This is the recent one, and according to it, the WRJ2 watershed falls in the critical category. This is the abstract part 1, and in the abstract of part 2, we can see that the area is covered by hard rock, and the recharge through rainfall, canal, surface irrigation, groundwater tanks, and water conservation is also computed in this abstract number 2. Results and conclusion. In 2015, GSDA and CGWB conducted the groundwater assessment, and at that time the stage of development was 4.69%. In 2017, it increased to 96.67%, and in recent 2019 and 20, the groundwater extraction is 99.37%. Means day by day and year by year, the extraction, that means the over-exploitation of the groundwater sources has increased. It's clearly seen from this. These are my references. I thank the Indian Science Congress for giving me the opportunity to present. I thank the PG Department of Geology, Nagpur University, Nagpur. Also, I thank Groundwater Surveys and Development Agency for allowing me to do this presentation, and lastly, the Central Groundwater Board. Thank you, sir, for listening so patiently. Thank you all.
Any comments from Vishnu?
Yes, sir.
You have mentioned critical watershed.
Yes, sir.
Why it is critical? What are the criteria to
Sir,
decide
because
it is critical?
the stage of development is between 90 to 100%. Means whatever groundwater sources are present over there, they have been exploited to their fullest limit. Now there is no scope.
Now, how you have decided that you will utilize?
So on the basis of observation well data, on the basis of various data which I have shown here, sir. So we collect various data from land use data, canal data, the recharge from
No, that's true, but
the recharge from.
in general, if you want to explain to the people,
Okay.
that these are the points, therefore we have kept this under the critical watershed criteria. So, what are the basis? What is the basis?
So the exploitation in that area, there is over exploitation due to the orange and citrus
No,
cultivation.
that theoretically it's okay.
Yes,
But
sir.
आपके इसमें actual क्या follow किया है points? Why it is critical? ऐसा clearly समझ में नहीं आ रहा. वो in general anyone can say कि यहाँ से exploitation ज़्यादा हो रहा है. But what you have actually found in your work, during your studies?
So draft जिस एरिया में ग्राउंड वाटर अवेलेबिलिटी जो है उससे ज़्यादा ड्राफ्ट हो रहा है, that is a critical condition, sir.
That is true.
Yes, sir.
But आपको क्या दिखा? कितना ड्राफ्ट है? कितना क्या अवेलेबिलिटी कितनी है? दिखा आपको?
हाँ सर. So ये ग्राउंड वाटर असेसमेंट है सर 1920 का.
आपका स्टडी बताइए.
हाँ सर, ये स्टडी CGWP and GSDA ने किया है सर. And I'm going to study this in my area also. And
So far you have not studied?
Yes sir, I have started it. And I'm going to check all these values in the field also, sir.
Okay.
Yes, sir.
So far you have not want to do it. Time. So thank you very much for your presence.
Thank you, sir. Thank you very much for your guidance.
Ladies and gentlemen, see, whenever we go and do a study of this kind, whether it is for groundwater or whatever it may be, I think first thing is we must know what we are doing. I'll give you an example from our own life. Supposing I get a marriage invitation card. So I must know that it is an invitation to attend a marriage. So there are certain duties and responsibilities involved with that. I have to carry some gift. I have to be properly dressed. Depending on in which party I am, whether from the bride party or the groom's party, there may be a difference in the dress style. The local customs I must be aware of. If I am not, I should consult somebody else. So in this also I feel, see when Professor was asking Godeswar, that what is critical, that word you are using. Supposing I am admitted to the hospital, I suddenly fall ill, collapse. You will lift me and take me to the hospital. The doctors will admit me. They will come out and will ask, sir, how is Mr. Badi? The doctor will say his condition is very critical. What are the reasons for which he says this? Critical there means probably he is going to die. His chances of survival are very limited. His pulse beat is bad, or his heartbeat is bad, or his blood pressure is bad, or something brainless, there is a hemorrhage or something like that. From which the present doctors with their available facilities are there. So similarly, when you say that the groundwater is in a critical status there, that means your recharge is not enough to sustain your demand. Supposing मेरे टंकी में पानी है, water supply municipality is 1,000 liters. If I want to spend 1,500 liters, I cannot. I will have to replenish it by some other. Maybe I will have to buy from somewhere. Once you do this kind of studies, then you know your object. And secondly, supposing if there is a community awareness program, then you should have some contact with the local community, whether it's panchayat, tahsildar, or district collector. And then you should know that you are doing this work, they should know it. You should take the local help. And when finally you find something, there should be some people who trust you. ऐसा नहीं होना चाहिए कि बाद में somebody to go, एक some girl had come from Nagpur University, she was talking something, अरे फालतू बात है. We have been using कुएं का well water for last, I don't know how many thousand years, nothing has happened. Today suddenly she comes and says that this water is not drinkable, it is contaminated, it has had salmonella infection. We have to do this, we have to do that. So that is the see, when I was a geologist in Geological Survey of India, way back in 1961, my first assignment was in Mandi district. I went from Simla to there in the month of December. I met the Tehsildar, with the district director, I met the local MPC, they were there. That was not then a state, it was called a territorial council. In the territorial council, instead of MLA, they used to call them MPC, territorial council. I met the members. I met some of the local people also. Teachers, doctors, engineers, whatever they are, civil servants, forest guards, foresters. You wouldn't believe, by the time May I left that place, next year, 61 December I was there, May I left because I was asked to go for a higher expedition in Padashiri. Everybody knew. Everybody in Karsuk Tehsil knew. Even nobody. Villagers. They knew that there is a Rabindranath who is doing survey. हमारे तहसील के लिए is doing good work. We may, if we find some mineral deposit, we will have to lifetime. That should be the kind of people around. My nephew became the district collector of Mandi somewhere in 1996 or 95. I went to visit him. When I told him that I had been in Karsuk Tehsil, these are the villages I had gone, these are the hills I had gone, these are the valleys I had seen. He said, I am the district collector, I have not yet seen them. Then I told him that Mahavir Singh was yours collector here. He said, you remember his name also? So, इस तरह का I would request you as geologists to make contact with the local.
अभी स्टूडेंट भी बैठे हैं, सबको ध्यान देना है.
No, I am particularly mentioning this for the students. So, Sabto is teaching.
Yeah.
So, not for the elderly people, for the younger generation. Leave an impact. Go anywhere you are. Just don't अपना routine. ये देखते हैं खाना खाने के खाने को निकाल दिया. हमारा अटेंडेंस हो गया या बस मारना है साइन कर दिया. बायोमेट्रिक में जब दिखा दिया. जाके वहाँ बैठ के कुछ नहीं किए. दिन भर से खाए चाय पिए गप मारे और निकल गए फिर बायोमेट्रिक. That is not the way we have to do. Because whatever you are going to do is going to have an impact on you. When I was a student, girls were not coming to study. Very few. And they used to be very isolated. Today, when I joined GSA, there were no women in it. But today, 40% of the geologists are girls. I see here there are also a lot of girls. Because I have also my 3 daughters. And I am proud of it. एक काम करिए करिए और इसी जैसे किसी ने सवाल पूछा आपने जवाब नहीं दे पाए कोई बात नहीं घर जाकर सवाल क्योंकि यहाँ पर मैं अभी देखते वक्त पढ़ते वक्त एक पढ़ा मैंने ठीक है somebody going to do some study on a Lomondite calcite veins in amphibolite of Chandradiga area, Alam city. All of you know Lomondite. How many of you know Lomondite? Lomondite. Alam Siddiqui, M. Alam Siddiqui. Anyway, if you go by developing it. Tomorrow I can come and
So, okay, thank you.
Thank you very much.
thank you.